Graphing piecewise functions. Piecewise functions are given in two parts. The most common piecewise function is an absolute value. First, let's look at how it works numerically. And the absolute value of 5 is 5. Absolute value of negative 5 is 5. So what it does is, if the number was positive originally, it keeps it positive, but if the original number was negative, it takes the opposite of the number. We can write this as a piecewise function, f of x, which equals x if x is greater than or equal to 0, but it takes the opposite for values that are less than 0. So this is the domain. So when x is less than 0, we use this, we can call it 2 and 1 just to refer to them. And if we graph it, we have to graph it in pieces. So the first part of the function says y equals x. That is a diagonal line, 1, 1, 2, 2, 3, 3. Now it starts at x equals 0, so we are looking at this part of the line. This is the line y equals x. Now we have a closed circle here because this is good for values that are greater than or equal to 0. Now the line y equals negative x is the line with a slope of negative 1, and together it forms a v. Now this one is good for x's that are less than 0, so technically it's an open circle, but it's filled in by the other piece. The next function we'll consider is f of x equals x plus 2. This is good for x's that are less than 2, and 4 for x greater than or equal to 2. Now the first one is a line y equals x plus 2. We'll graph that first. Now, normally we choose any x that we like, but this is good for x less than 2. So we can plug in 0. If we plug in 0 for x, let's make an xy chart here. We can plug in 0, and then y would be 2. And then if we plug in 1, we get 3. So we have 2 points, but we're not done, because we want to plug in 2, even though we're not supposed to. We could plug in 1.99999. So if we plug in 2, the output would be 4. And we use an open circle when we plot this point, because we're not supposed to include 2. So we could have chosen any negative value for x. And I shouldn't have drawn an arrow there. There's no arrow there. It's just an open circle there. Now for the other piece, it's the line y equals 4, which is a horizontal line. Now the smallest value that we can plug in is 2. And when we plug in 2, we get 4. And we'll always get 4. So it's a horizontal line that goes like this. So the first piece extends out forever, and the domain of this function happens to be negative infinity to infinity. The next example has 3 pieces. F of x equals x squared. This is good when negative 1 less than x less than or equal to 2. Second piece, the horizontal line y equals negative 2. That's good for x's that are greater than 2 and less than or equal to 3. And the final piece is the line x plus 1, which is good for x's that are greater than 3. Notice that the first piece is a parabola. We can plug in negative 1. Negative 1 squared is 1. So the point negative 1, 1 is on here. We can also substitute 0. 0 squared is 0. And 1. 1 squared, 1. And finally we plug in 2 into the squared function. And when we do that, we get out 4. Now this is going to be a closed circle because we can include 2. So that is our first piece. Both of them will be closed because we have less than or equal to and on both of them. Then we have a horizontal line, y equals -2. Now that starts at 2 but does not include 2 and goes up until 3. So here's -2. So we have an open circle because we can't substitute 2, but once again we could do 2.0001. And we stop when we get to 3. So when x is 3 and includes 3, the y value is 2, -2. And we connect that. That's the second piece. Then we have the line x plus 1. So that's good for x is greater than 3. If we substitute 3 into the third piece, the output is 4. And it's going to be an open circle because we can't plug in 3, but we could do 3.001. We substitute 4. 4 plus 1 is 5. And now we have our line. Notice it passes the vertical line test, so it is indeed a function.